In the continuation of rank of the matrix, this is the part of in this part, we discuss about the corollary of the normal form, outline corollary of normal form, and the problem. Corollary of normal form, if A be a matrix of order n cross n and rank R, then there exist non-singular matrices P and Q such that PAQ is in the normal form. We already discussed about the normal form in part 3. We have the 4 types of normal form. So we have a PAQ is any one of the normal form. Let us understand the corollary of the normal form by the example. So let us take the first example. Find two non-singular matrices P and Q such that PAQ is in the normal form and hence find the rank of the matrix. This matrix contains the 2 rows and the 3 columns. That is, this can be written as 2 cross 3 and A can be written as I2, the identity matrix of order 2 by corresponding the number of rows A and I3. I3 is the identity matrix of corresponding the number of columns. That is 1, 2, 3 and 3, 1, 2. I2 is equal to 1, 0, 0, 1 A and I3 is equal to 1, 0, 0, 0, 1, 0 and 0, 0, 1. We convert this matrix A into the normal form by using the elementary row and column transformation. If we apply the elementary row transformation, then we changes in the pre-matrix. And if we apply the elementary column transformation, then we changes in the post-matrix. So the first row operation is R2 replaced by R2 minus 3R1. It is 1, 2, 3, 0. 1 minus 6 minus 5, 2 minus 9 minus 7. Here 1, 0 minus 3 and 1. A 1, 0, 0, 0, 1, 0 and 0, 0, 1. Apply the column transformation. With the help of this column, we make this element and this element is 0. So C2 replaced by C2 minus 2C1 and C3 replaced by C3 minus 3C1. 1, 0, 0, 0, minus 5, minus 7. Now we apply the column operation. So we changes into the post matrix. Minus 3, 1. Okay. 0, 0, minus 2, 1, 0, and minus 3, 0, 1. So here we apply the row transformation as well as the column transformation. If we apply the row transformation, we make changes in here. If we apply the column transformation, then we change here. So if we apply the column transformation, that is C2 replaced by minus K1 by 5 C2. This becomes 1, 0, 0, 0, 1, minus 7, 1, 0, minus 3, 1, 1, 0, 0. The entries are 5, 5, minus 1 by 5, 0, minus 3, 0, and 1. corresponding matrix. Now, with the help of this column, we make this element is 0. So, C3 replaced by C3 plus 7C2. 1 0 0 0 1 0 1 0 minus 3 and 1 1 0 0 2 by 5 minus 1 by 5 0 1 minus 7 5 5 minus 3 plus 14 by 5, that is minus 1 by 5, which is a normal form. The identity matrix of order 2 and the null matrix of order 2 into 1 is 1 0 minus 3 1 8 1 0 0 2 by 5 minus 1 by 5 0 minus 1 by 5 minus 7 by 5 and 1. So here non-singular matrices are, first one is 1 0 minus 3 and 1. Second is 1 0 0 2 by 5 minus 1 by 5 0 minus 1 by 5 minus 7 by 5 and 1. And the rank of the matrix is because here identity matrix of order 2. Now move to the second example to better understand the corollary of the normal form. Find non-singular matrices P and Q such that PAQ is in the normal form, first part, and hence find the rank of the matrix, the second part, and the third part is also find the AUs. So the given matrix is having the 3 rows and 3 columns. So this matrix can be written as A is equal to I3, A, I3. This I3 is correspond to the number of rows and this I3 is correspond to the number of the columns. Matrix is 3 minus 3 and 4, 2 minus 3 and 4, 0 minus 1 and 1. Entity matrix 1 0 0 0 1 0 0 0 1 A 1 0 0 0 1 0 and 0 0 1. So make this matrix into the normal form by applying the elementary row and column transformation. So the first is R1 is replaced by R1 minus R2. Get 1 minus 3 plus 3 0. 4 minus 4 is 0. 2 minus 3, 4, 0 minus 1 and 1. So here R1 minus R2, 1 minus 1, 0, 0, 1, 0, 0, 0, 1. Because we apply the elementary row transformation. So we make the changes in the pre-matrix. 0, 0, 0, 1. The post matrix is same is here. Now with this row, making this element is 0. So R2 replaced by R2 minus twice R1. 1, 0, 0, 0, 3, 4, 0, minus 1, 1, 1 minus 1, 0, R2 minus 2, R1, so minus 2, 1 plus 2, 3, 0, 0, 0, 1. Now, next is R2 replaced by minus R3. It is 1, 0, 0, 0, 1, minus 1, 0, minus 3, 4. Apply the row operation. So the post matrix is as it is. One minus 1, 0, 0, 0, minus 1, because we apply the changing. Then minus 2, 3, 0. With the help of this, making this element as 0, so R3 replaced by R3 plus 3 R2 is 1, 0, 0, 0, 1, minus 1, 0, 3 plus 3, 0, and 4 minus 3 is a 1. Is 1 minus 1, 0, 0, 0, minus 1, minus 2, 3, minus 3. One, 0, 0, 0, 1, 0, and 0, 0, 1. Next, with the help of this element, making this element is 0, so C3 replaced by C3 plus C2 is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Here we apply the column transformation. So we change into the post matrix. Minus 3, A, 1, 0, 0, 0, 1, 0, and 0, 1, 1. So this is the form of I3. This is the PAQ, where P is equal to 1 minus 1 and 0, 0, 0, minus 1, and minus 2, 3, minus 3, and Q is equal to 1, 0, 0, 0, 1, 1, and 0, 0, 1. Rank of the matrix is the order of the identity matrix. Here the order of the identity matrix is 3. So the rank of the matrix is 3. Then next is to find A inverse. Matrix can be written as I is equal to PAQ. So we pre-multiply by P inverse. I is equal to P inverse PAQ. And we know that P inverse P is equal to I and P inverse is equal to that is IAQ. Again, we multiply the post inverse, that is IA, Q and Q inverse, P inverse, Q inverse is equal to IAI, it is A. So A can be written as inverse Q inverse implies A inverse is equal to QP. We find out the inverse by using this formula. So A inverse is equal to Q is 1 0 0 0 1 0 0 1 1. P is equal to 1 minus 1 0 0 0 minus 1 minus 2 1 3 minus 3. Now taking the matrix multiplication, this goes to this column. We get 1 plus 0 plus 0. Let's multiply by this. Rows multiplied by this. Minus 1 plus 0 plus 0. So multiply by this. 0 multiplied by 0 multiplied by 0. Again, this rows multiply by this column. So 0 multiply by 0 minus 2. So multiply by this 0 plus 0 plus 3. Let's multiply by this column 0 minus 1 and minus 3. This row multiply by this 0 plus 0 minus 2. Let's multiply by this 0 multiply by 0 plus 3. And this multiply by this 0 plus 0 and minus 3. So it becomes 1 minus 1, 0 minus 2, 3, 3 minus 1 minus 4, minus 2, 3 and minus 3. This is the A inverse. These are the references. Thank you.